Good afternoon, everyone. I'm Travis Spivey, joined my son Jordan Spivey, representing FSI Courses. And in today's video, we're going to actually do part two of Waves assessment questions. So let's begin. Number one, the model shows how light waves are transmitted through a transparent substance. How would the model be different for a sound wave that is being transmitted through the same substance? The key to this question is understanding how light waves travel. So let's go ahead and get our pen, laser pen out. Now, let's look at light waves. All light waves are electromagnetic waves, and all electromagnetic waves travel perpendicular to the medium. So let me put that. They travel perpendicular to the medium. So all electromagnetic waves actually look like this. And that means they travel in L's to the medium. That's what perpendicular means. But then if you look, how would the model be different for a sound wave? A sound wave is a type of mechanical wave, and it is a longitudinal mechanical wave. And now sound waves actually travel parallel to the medium. So I'll show you what that looks like. So sound waves look like a slinky. And when we say parallel, that means they travel side by side the medium. So now let's look at our answer choices. A, the wavy arrows representing sound waves. First of all, wavy arrows would not represent sound waves because sound waves actually look like a slinky. So we can cross that out. Look at B. The wavy arrows, we can go ahead and cross that out again because once again, sound waves are not wavy. They actually look like a slinky. Look at C. The atoms in the model would move parallel to the direction. So our answer choice is C, and they would move parallel, just like I stated earlier, to the direction of the incoming wave. And then D, the atoms in the model would move perpendicular. We discussed that earlier. Sound waves are not electromagnetic waves, so it would not be A, B, or D. Our answer choice is C. Number two, the picture below shows what a toy figure looks like when part of it is placed into a glass with water. Which statement explains what happens to the light to make the toy figure inside of the water look different? Ladies and gentlemen, the key to all of these questions is understanding the definitions of wave behavior for reflection, refraction, diffraction, and absorption, and also how does each wave behavior look? So now I understand the definition for them. So I'm looking at this. This light wave is traveling from a gas to a liquid. That means there's a light wave that's traveling from a gas to a liquid, and it's causing that light wave to actually bend as it goes from one medium to the next. And that means that light wave is actually going to be refracted. Once again, once you understand the definitions for wave behavior and you know how the wave behavior looks for refraction or diffraction, absorption or reflection, then it's easy to get this question right. So look at A, the light was refracted. So our answer choice is A. B, the light was reflected. Definitely not. C, the light was absorbed. No, because it would show the light wave doing this. Once again, for reflected, it would show it bouncing off. And then D, the light was destroyed. Absolutely not. 3. Which illustration shows the path of a ray of light as it enters and travels through a glass of water? Once again, this ray of light is going from a gas to a liquid. So if you know the definition of a light wave or a sound wave traveling from one medium to the next, then you automatically know that that's actually going to be refraction. And when you think of refraction, you should always have the image of that light wave bending, that light or sound wave bending as it travels from one medium to the next. So let's look at this. It can't be A because it's showing absorption, but look at B. Look at this light wave bending ever so slightly right here. So our answer choice is B. Look at C. That's showing absorption again. And then look at D. A light or sound wave are not going to bend or refract that much as it travels from one medium to the next. Number 4. The picture shows three light rays from the sun that are traveling toward Earth. What happens to light ray X? Look at light ray X. If you know what this looks like, or you know the definition for the actual diagram or picture right here, you automatically know that that is actually being reflected. So X is actually being reflected. So let's look at A. It is absorbed by space before it reaches Earth's atmosphere. It's not A. B, it is reflected back into space. So that means it bounces off Earth's atmosphere and reflects back into the space. So our answer choice is B. Look at C. It says it is slowed down. That means it's implying that it's actually being refracted. So that means it's bending as it enters Earth. That is definitely not true. And then look at C, and look at D. It is transmitted around the planet by particles in Earth's atmosphere. Absolutely not. And so our answer choice is reflection with B. 5. The graphic shows a red light shining on objects Q and R. Object Q appears to be black and object R appears to be red. Which of the following is correct? So if a substance is black, that means it absorbs all of the colors, all the colors of the electromagnetic spectrum. If a substance appears to be red, that means all of the other colors are being absorbed except red, and that's what's being reflected back to our eyes. So look at A. Object Q reflects red light. No, object Q does not reflect red light. It actually absorbs it. That's why it's black. B. Object Q diffracts red light. No, it doesn't diffract it. Once again, it absorbs it. C. Object Q absorbs red light. That is true. And object R reflects red light. That is true. And that's why, since it reflects it, that's why we see it as red, because that's what's being reflected back to our eyes. So the answer choice is C. And then object Q refracts red light. Nope, it does not do that as well.